Okay, Rach, let's tackle that perbromate ion again. Okay, so let's take that. It's going to be BrO4 minus. Alright, so let's count those valence electrons. You have 7 for bromine. You have 4 times 6 for those 4 oxygens, plus you have that 1 electron that forms that charge. And so that's going to give me a total of 32 valence electrons that I have to account for in this particular structure. So the perbromate ion, we'll put the bromine in the middle, and we'll put those 4 oxygens around that. Okay, and if we go ahead and put those valence electrons around those terminals so that we form those octets that we like to do, then this structure right here could be a valid Lewis dot structure for the perbromate ion. Now, one thing we have to consider here is the formal charges. Okay, so even though this is valid, it might not be the best. And what we want to do is we want to minimize the formal charges. So if I do this, remember that formal charge that we talked about, the way that we're going to look at it is going to be the valence electrons minus the dots minus the lines, just to make it easy for us. We already talked about the real way of thinking about it. So let's look at that bromine. So bromine right there, that's going to be 7 valence electron. There are no dots in this particular structure, and there are 4 lines, and so that will give us a formal charge of +3. Now that's pretty high. We want to reduce that as close to 0 as possible. If we look at each of those oxygens, then oxygen has 6 valence electrons from the periodic table. If I count the dots, I got 1, 2, 3, 4, 5, 6. I've got 6 dots. And I've got the 1 line, and so that's going to be a -1 for each of those oxygens. But let's see if we might be able to reduce those formal charges. Now, one way we can do that, just looking at our formula here, is if there's no dots around the bromine, but if I have 7 lines, then that will go ahead and reduce that formal charge to 0. Let's see if we can draw a Lewis dot structure that looks like that. So we have bromine, we have those 4 oxygens around there. Okay. So now I have 4 lines. We can try to get that to 0 by adding 3 more lines, okay? Because the valence electron is 7. There are going to be no dots around there, and so we need 7 lines, 7 bonds, so we can reduce that formal charge to 0. So if I go 1, 2, 3, 4, 5, 6, 7, okay, now that formal charge around the bromine is going to be 0. So let's go ahead and form those octets by putting 2 valence electrons around each of those. We'll have 1, 2, 3, 4, 5, 6 around the single bond, and then 2 again. Okay, so if I count up the electrons in this, there are 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 26, 28, 30, 32. So this is a valid Lewis dot structure. But notice what we've done. We've actually reduced that formal charge on the bromine. And so let's just look at those oxygens to see if formal charge is reduced in each of those. And so let's look at the 3 oxygens with the double bonds around them. So the valence electrons is 6. The dots around those are 1, 2, 3, 4, minus 4, minus lines, minus 2. Okay, so that equals 0. So the formal charge on this oxygen, and this oxygen is going to be 0. The formal charge on the bromine, we already said, is 0. And so what's left is this formal charge on that oxygen with a single bond to it, which is going to be 6, minus dots, which is 6, minus that 1 line. And so the formal charge on that will be a -1. Now notice the difference here. So if we go over to this original structure, looked right and looked appropriate, the formal charge on the bromine was a +3, and then on each of these oxygens is a -1, a -1, a -1, and a -1. So all of those have a higher formal charge than 0. If we come over to this structure, The formal charge on this oxygen is 0. The one on this oxygen is 0. The one on this oxygen is 0. The one on this oxygen is the -1. And the bromine is a 0. So by forming those extra bonds, then we were able to reduce those formal charges. So this is actually the better Lewis dot structure for the perbromate ion. Now, how would you know that? Well, it turns out if you look where bromine is on the periodic table, bromine itself is able to handle, because it has higher orbitals that will be involved in bonding, even though this bromine completely violates that octet rule. We have 2, 4, 6, 8, 10, 12, 14 electrons around there. Completely violates the octet rule. By looking at formal charge, we're able to maybe make a better Lewis dot structure by reducing that formal charge. So this is how we would do the correct perbromate ion.